So we have situations where polyatomic ions are formed. And this happens because sometimes atoms bond, but they do not get all the electrons that they need. So we're going to look at how we can form ions, but then they still need to be attached to something else. So here we have oxygen. It's picking up an extra electron. So it does want the electron from hydrogen, but it needs one more to have full shells and for hydrogen to be empty. So what happens is we actually get an electron from sodium. So oxygen's getting an electron from hydrogen and getting an electron from sodium. But what happens is we keep that hydrogen and oxygen together. They're technically sharing one, and then it's pulling one from sodium. So when we were talking about is it ionic or is it covalent, we ignored the possibility that it could be both. So the oxygen and hydrogen are sharing, and then they're stealing one from sodium to make them complete. So sodium needs to get rid of one. That little couple needed to gain one to be stable. So let's look at an example here. We have Al and we have OH3. So aluminum has 3 to lose. Hydroxide we just said would have a -1 charge, so it has 3 it needs to gain. When we name them, we want to look at just the first element. We want to just say its name. So Al stands for aluminum. But then we get to that second set or elements after that. We need to look at our little chart and see what the name is. Hopefully these will come to you a little naturally or become secondhand, because when we get to chemistry class, we need to know a lot of them and we don't want to have to be looking them up. So we have Al, aluminum, and our chart says OH is hydroxide. Notice we're not talking about that 3 at all. We don't need to be concerned about that. It's being used to help balance out charges. So for the polyatomic ion, we have OH. He gets a name hydroxide. We don't say hydrogen, oxygen, or oxygen, hydride, or anything. It's hydroxide. It has one specific name. So here are some more examples. We have Na, so it's still sodium. We don't need to worry about that too. But then we have SO4. So SO4 stands for one big cluster, and that's sulfate. Na2, once again, ignoring the 2, is still sodium, but then we have CO3. So CO3 is carbonate. Our third example, we have Mg. Mg stands for magnesium. And then we have the OH. It's in parentheses because we need 2 of all of them. But when we name it, we don't talk about the 2 or the parentheses. We just say hydroxide. So we have magnesium hydroxide. We have next calcium, and then NO3 stands for nitrate, and we do need 2 of those to counteract the Ca because nitrate is a -1 charge, so we gotta keep it all neutral. Our next example, we have K, that is potassium, and now we have ClO3, that is chlorate. The whole ClO3 ion becomes a -1 charge, and potassium is a +1 charge. They cancel out, so we don't have any extra subscripts or parentheses there. And then lastly, we have Ba, and then we have PO4. The Ba becomes barium. Its 3 is telling us the charge of phosphate. Then we have phosphate, which is PO4, and his charge is a -3, and the barium's charge is a +2. So in order for them to cancel out, we have to use those charges and kind of use that little math concept of common multiples. And what do we have to multiply by? We have to multiply barium by 3. So 3 times a +2 charge gives you +6. Phosphate's charge is -3, so we have to multiply it by 2 to give us -6. And that gives us a total charge of 0. So I told you the other day that when we do bonding, we have to have the net charge of 0. So we will do some more practice with this in class, but just to give you an idea of how to name, I think these are kind of easier to do. I would like you to work on some of them, and I think it's harder to actually go from the name to the formula because then you have to create subscripts.